Hello students, today we will see example number 2.2. Here in this example, two charged particles Q1 and Q2 separated by distance r is given, and here we want to find the point at which the potential due to this charge is 0 on the line joining the charges Q1 and Q2. So we can say that this is the line which joins Q1 and Q2. On this line, the potential can be 0 at 2 points. One between the charge Q1 and Q2, and the other towards charge Q2 on this side. Now it is because one of the charge Q1, which is at point O, is having positive magnitude, and the other charge, which is at point A, is negative. Also, the potential cannot be 0 at this point. It is because here the magnitude of this charge is larger than this charge, and so magnitude can be 0 at this side and not towards this side. We know that the potential due to any system of charges at any point is the summation of the potential due to the individual charges. Means, if I want to find the potential at this point, then here at point P, the potential is due to this charge as well as due to this charge. And so we will apply simple method that the total potential or the resultant potential V is equal to potential due to first charge Q1 plus potential due to second charge V2. And here we have taken the condition that the potential is 0 between O and A. Means at this point, which is between O and A. Now, formula for potential V is K Q by R. We know that V is equal to, actually it is 1 upon 4 pi epsilon naught charge Q upon distance R. But here in place of 1 upon 4 pi epsilon naught, we can write in short as constant K. But when we write K here, we need to mention that K is 1 upon 4 pi epsilon naught. So here also we will use this formula that potential due to charge Q1 is K Q1 upon distance x. Similarly, potential due to second charge is again K but charge Q2 upon distance r minus x. Now I will show you this distances in the figure. You can see here we want to find the potential at this point. So for first charge Q1, the distance of this point is x. So we have taken the distance x. Again, this point P is this much distance away from charge Q2, and this distance is r minus x. So we'll get this much distance because already we know the distance between O and A. This distance is known, and this distance from charge Q1 to P is already taken as x, and so this much distance from charge Q will be r minus x. So we have taken this. Now calculation part. Here the value of this charges Q1, Q2 is given. Also this distance between the charge Q1 and Q2 is also given. So now we will put these values. Q1, which is equal to 3 into 10 raised to minus 8. Q2 is minus 2 into 10 raised to minus 8, and distance r is 15. Now after putting these values and also the potential, resultant potential is 0, so we have kept that V is equal to 0 at point P. So after putting these values and calculating, we'll get the answer x is equal to 9 centimeter. Students, calculation is quite simple. See, in both these terms, k is constant, which is common in both, so that is taken out, and when this k is brought from right hand side to left hand side, so 0 upon k will be 0 only, so we can simply remove this k. Also here 10 raised to minus 8 in this term, as well as 10 raised to minus 8 is there in this term, so that can be taken out common, and again that will become 0 when it is brought on the left hand side. So only remain is 3 upon x and minus 2 upon 15 minus x. So the next step will be this, and finally cross multiplication. 3 into 15 minus x is equal to 2 into x, and then simply making the subject x, will get x is equal to 9 centimeter. So this is about the point between the two charges. So here we obtained the distance at which the potential is 0 from this point O. Now the potential can be 0 even at this point towards A, because this charge is having less magnitude, so possibility of the potential to be 0 will be towards this side only, not towards this side. So again from point O, taking the distance of P dash as X dash, at which the potential is 0. So now here we have taken this distance X dash, and now applying the method, that potential V dash, which is at point P dash, is equal to the potential due to first charge V1 dash plus potential due to second charge, that is V2 dash. Now here we have taken this dash, it is because now the distances are changed, and so we have to make little difference in the symbols. Again the formula is same only as earlier. See, we have used the formulas here. Similarly, we are using the same formula here also. Potential is 0, V1 is K Q1 upon new distance X dash plus K Q2 upon X dash minus R. Why it is X dash minus R? It is because this point P dash, its distance from this charge Q2 is this much. Already this distance is given. This distance we have taken as X. So this much distance will be X minus R. X minus R. So we have kept this. Now as earlier, simply putting the values, we'll get next step. In this step, K is taken out common, as well as 10 raised to minus 8 here in this term, and 10 raised to minus 8 in this term, that is also taken out common. And then when we'll bring that towards left hand side, so 0 by anything will be 0. So only remained here is now 3 upon X dash minus 2 upon X dash minus 15. And so I have written this next step. Now again cross multiplication, 3 into X dash minus 15 is equal to 2 into X. Now here remember that this term was negative, this second term was negative. So when we'll bring that term on the left hand side, it will become positive, and that's why here this is became positive. Similar as this step. Finally, making subject X dash, will get the answer 45 centimeter, and hence finally we can say that the potential is 0 at distance 9 centimeter as well as 45 centimeter from point O on the positive X axis. From point O, first distance at which the potential is 0 is this, which was 9 centimeter, and from point O, the second distance at which the potential is 0 is 45 centimeter. Now students, one more thing, if both the charges were positive, here this was positive in this case and this was negative. But if both are positive, then we cannot find any point on the line joining Q1 and Q2 where the potential is 0, because at any point the potential due to this charge is also positive, even potential due to this charge is also positive. So both the positive will be there, then there is no chance of 0. Even if we'll select any point this side, then also potential due to first charge which is positive, so potential is also positive here. For second charge, if it is positive, then the potential here will be positive. So there is no chance of potential to be 0 if both the charges are positive, or if both the charges are negative, then also potential cannot be 0 anywhere. Now one more possibility. Here the magnitude of this charge is more in this case and this is less. One is positive and the other is negative. So we can find a point on this line where the potential is 0. But if the magnitude of this charge is less than this charge, then we will find a point on this side where the potential is 0 rather than this point. If magnitude of Q1 is less than this, in that case at this point or towards this side the potential can be 0. But here in this case the magnitude of this Q2 was less than this, and so this point has the potential 0. I hope you understood this example. Now let us move to next example. Example number 2.3. The questions given in this example can be asked in the form of MCQ. Now students, if the topics which were studied earlier is clear to you, then you can easily answer these small questions given in these examples. So this example is only to revise, we can say, the previous topics and to check whether that topics are clear to you or not. Now here in this example, two figures are given, figure A and figure B. In first figure, a positive charge is there, and so the electric field is radially outward. That is also shown, and 2 points in this electric field is given, point P and point Q. Similarly, in second figure, a negative charge is given. Once again, the electric field is radial, but it will be moving towards the charge. This you already know. And here 2 points are given, point A and point B in this electric field. First question asked is A. Give the signs of potential difference Vp minus Vq as well as VB minus VA. Now here the difference VP minus VQ, that is the potential difference. So result of this potential difference is positive or negative, that we have to answer. Now let us see this figure. Potential due to positive charge at any point around it will be positive. So here the potential at point P will be positive, as well as potential at Q will be also positive. But as this point P is closer to this charge, the potential at point P will be larger than the potential at point Q. Why potential at point P is larger? It is because we know that potential is inversely proportional to the distance r, because we have this formula of potential V is equal to K Q by R. K is constant and the charge Q for which the field is given, that is also constant. So if we'll remove this constant, we'll get this proportionality. And so if the distance is less, potential will be more. And so potential at point P is greater than potential at point Q. And so if we'll bring this VQ this side, so VP minus VQ is greater than 0. So this difference is greater than 0 means it is positive. So we obtained the potential difference VP minus VQ, which is positive. Now about VB minus VA. Will it be positive or negative? Once again, let us see the figure. Now here the charge was positive, and so this potential was larger and this was smaller. So larger minus smaller, the sign will be definitely positive. But here in this case, this charge is negative. So situation will be reverse of this. Here in this case, the point which was closer has larger potential. But here the point which is far away has the larger potential. And this point has a smaller potential. Remember, the magnitude of potential at this point will be large, but as this charge is negative, this potential will be negative. So more the negative, value will be less. So here more negative potential and here less negative potential. So we can say, as the case is reverse, potential at point A will be smaller than B. Once again see the figure. This potential is more negative, so this is smaller than this less negative potential. So potential at point A is smaller than potential at point B, or we can write potential at point B is greater than A. See, simply reversing this condition. So after that, bringing this A on this side, we will get VB minus VA is greater than 0. And so as this difference is greater than 0, we can say that it is positive. Next question asked here is, give the sign of potential energy difference of a small negative charge between the points Q and P as well as A and B. Now potential energy difference is given. So for this first case, the potential energy difference will be UQ minus UP. Now we know that the formula for the potential energy, U is equal to Q into V. This is the charge which is brought from Q to P. So that charge into potential is potential energy. And in this formula, if we'll take the delta, that is difference, then if we'll take here difference, then there will be difference in the potential. This is not going to change, which is brought from Q to P. So if the potential changes, we can say potential energy also changes, and that's why there is delta, and delta means difference. So UQ minus UP is equal to Q into difference in potential. Now we already know the difference in the potential, these two. In earlier case, we got the difference Vp minus Vq as positive for that first figure. So if Vp minus Vq is positive, then what will be Vq minus Vp? That will be negative. So Vq minus Vp will be negative, and here that is given Vq minus Vp, which will be negative into this charge, which is negative. This charge which is brought from point Q to P is also negative. So negative into negative will be positive, and hence the potential energy difference finally will be positive. I have written here negative into negative will become positive. Similarly, you can find the potential energy difference UA minus UB, whether it will be positive or negative, in the same sense as we have done earlier for this. So that is your self work. You will be easily able to obtain that. Even that difference you will find it positive. If any doubt is there, you can ask me. Now next is about what will be the sign of the work done from Q to P in moving a positive charge. Now from this given figure, the charge is given here, and so the electric field will be outward. Now a second unit charge Q is brought from Q towards P. So I have drawn that figure also in a simple way. You can see this charge due to which there is an electric field, and a unit positive charge is brought in this direction. So we know that here the work done, W, is always force into displacement, but it is in a dot product manner, F dot D. Now here it is given that the work done by the electric field is to be obtained. You can see in the question, the work done by the field is to be obtained. Now if this positive charge is kept here, then the force due to this charge will be repulsive. That means its direction will be this. Electric force, its direction is towards outward. But we are going to displace this charge from Q to P. And so we can say easily that the force and the displacement both are in opposite direction. So here also in this formula, as this F and D, they are opposite to each other, when we remove dot product, will give negative sign, because if two vectors they are opposite to each other, then angle will be 180 degree. And when we remove this dot product, we know that we used to write F D cos theta, and if theta is 180, then cos 180 will be -1, and so there will be negative sign, and hence we can say that the work done by the field will be negative. Now this question can also be asked in this way, that what will be the work done by the external force. In place of work done by the field, the simple change can be made as an external force. Then if the external force will be there, then that will be positive, because if we want to move this charge from here to here by external force, then force will be in this direction, even displacement is in same direction, so angle will be 0 and cos 0 will be 1, and so F into D will be positive if the external force is given here. Then next is also similar kind. What will be the work done from B to A? So this is for the second figure. You can see here this figure, the charge is negative, and here we have to bring a negative charge from B to A. Once again, here negative charge is to be brought from B to A. If we'll put this negative charge at point B here, then this is also negative, and here this charge is also negative. So once again, electric force is repulsive, that is in this direction, but we want to bring this charge from B to A, and so the external force required will be in this direction. So here external force and displacement both are in same direction, and as both are in same direction, work done will be positive, because in this case here it is asked that what will be the sign of the work done to bring this negative charge from B to A by external agency. If it is asked that by electric field, then once again the sign will be reversed. this will become negative if the work is to be done by the electric field. But here the work is to be done by the external force, and so the sign is positive. Now for this next question, the situation is same as earlier, but here it is asked that what will be the kinetic energy when this charged particle will move from B to A, that is in this direction. So definitely both these charge are negative, this as well as this. So force acting between them will be repulsive. That means in this direction the force will act on this charge Q, and if it is moving, that is this charge is moving in this direction, and if the force due to this charge is in the opposite direction, then definitely we can imagine that its velocity will decrease, means velocity of this charged particle which is moving in this direction will go on decreasing. And we know that the kinetic energy is related to the velocity also, and if the velocity decreases, definitely the kinetic energy will also decrease. So I hope you understood this example.